And let me make you the host so I can disconnect.
Okay, can we start?
Yes, I made you the host now, so
no. Okay,
yeah.
That's fine. Thank you.
And we'll do the recording as I'm back. Okay.
Okay.
Thank you. Enjoy the weekend. Bye.
Oh.
Thank you.
Okay. Thanks. Good evening, everyone from Nigeria. Today we'll be looking at applied networking. In the previous class, we looked at networking, the concept. Here we're looking at how the networking concept can be applied. And so I want to believe everyone as they attempting their chapter exams, be sure that you're following. I believe there are no issues. So we'll be looking at the objectives for chapter 6. We're meant to configure device for wired and wireless network, looking at the different network connection, explain what MAC and IP addressing for computer networks are, configure a NIC for wired and wireless networks, configure wireless networking in small LAN, configure firewall settings, configure IoT devices, and then troubleshooting, network troubleshooting, and then looking at troubleshooting problems and solutions related to networks, and then explain the 6 steps of troubleshooting process for network. We'll also look at troubleshoot common and advanced problems related to network. There's a video while you are reading through the resources. You should be able to follow through to give you a guide on IPv4, IPv6, and all of that. Then let's go straight. Network addressing. If you look at it, you see the picture on the left-hand side. You're looking at the main address, and so it's so obvious that if information must move from one point to the other, looking at the human-to-human communication, sometimes we send mails, physical mail, but in the network world, you're looking at IP address as a means of actually sending information from one system to the other. That's also in line with the MAC address of the corresponding systems on that network. And so for network address, we have 2 types, the IPv4 and IPv6. The IPv4 is actually classified into 5 classes, class A, B, C, D, and E. Okay, I'm going to take it one after the other. So we're primarily looking at IPv4. So the entire bit length of an IPv4 is usually 32 bits. And then it's divided into 4 octets. 4 octets with a dot in between. So you can see here 192.168 is actually numbers in different strings, but each of these strings is actually made up of 8 bits. These 8 bits represent the octet, and then this 8 bits, when converted into decimal, will give you values like this. For IPv4, usually, like I said, we have from A to class E. For you to know numbers that are actually assigned to each of the classes, from class A, when you talk about class A IPv4, is usually from 0 to 1 to 7. And then the class B is 1 to 8 to 191. I want to believe you write this down. is 192 to 223, and then class D is from 224 to 239, and then class E is 240 to 255. So once you get that rate, it tells you automatically which class of IPv4 you actually operating in. So I advise that we take these numbers seriously. So the first value of number in the lineup tells you which class it belongs to. For instance, it actually belongs to the class A. And that is for, sorry, class C rather, because I said C is from 192 to 223. So the first number actually is the determinant. It is the class C IP IPv4 address. And like I said, it's a 2-bit length. But what you're seeing here beneath the IPv4 is an IPv6. An IPv6 is 128 bits in hexadecimal format. And this 128 bits you can see is more than 32 bits. 3.6 under C IP addresses. That tells you that we have so much IP addresses when it comes to the IPv6. Actually, we have virtually exhausted most IPv4 address, and there's a need into IPv6. So the transition has already been in place. Many organizations have actually migrated, all because of the limitation with IPv4. And so that the IPv4 is actually separated with a dot. Actually, this dot is just to make it easy for us to understand. But the computer system sees them as one, numbers. But then, for ease of comprehension, the dot is used to separate one decimal numbers from the other. Therefore, the IPv6, instead of a decimal number, sorry, instead of a dot, and you can see, and each numbers for you can see here the category of numbers you have for a column, and that column presents what we call hexagon, or we call it nipples. So if you count the number of hexagons we have here, represents 16 bits. So if you multiply 16 by 8, you get 128 bits. Okay, and it's usually 1 and 0 dB8 and of slash 64. So 64 in the sense that the first 64 bit is referred to as ID, and then the remaining 64 bit is referred to as the host ID. In other words, that is the IP address that are assigned to other systems on the network, as in other words, for the host. And then unlike for IPv4, where we have them in different classes, each class, I'm going to explain that further. We have subnet, things we'll discuss when we get to CCNA1. But then, under the IT essentials, of course, you need to have some basic knowledge on how these numbers are being. So, this simple example to show for. And so, you can see here that the IPv6 is actually in hexadecimal numbers. So, each of these numbers here can be split into binaries. So, each of them actually represents 4 bits. And by the time you put it up together, you have extent. And then by the time you put all together, you have 128 bits. Another thing also you could see here in the IPv6, mainly looking at it also, is that IPv6 has what we call compression and suppression method as a way of trying to reduce or compress this number so you don't have that. And so what happened? The rule number 1 says that you can eliminate any leading zeros. In other words, if any of the hexagons begins with a 0, you it off. The computer still understands that it actually can tell that that number exists there, that 0 digit exists there. But for simplicity, we take it these zeros from this, so that you can have it as 2001 column DB8 that you see down here. and CFE, and then when it comes to you eliminate, you take the leading zero, which is 0, and then you have 200. And the rule number 3, and Sudan said, where you have bits of zeros, actually maybe in 2, 3, 4 strings, all line up together, you compress, you use them as double columns. So where we have 0, 0, 0, 0, you can see it here, and next again is 0, 0, 0, you can see next 0, 0, 0. These 3 kind of 0 bits. So what happens is that they are represented with what we call a double column. And then remember, we remove all the leading zeros for each of the strings. So the 0008 automatically becomes 8. So you can see that this IPv6 address has finally been compressed into. So the suppression takes place and then the compression, bringing you to a simplified IPv6 address. And so two network addresses. Looking at the network address, when a laptop is moved to a different network, the MAC address stays same, but the IPv4 and IPv6 address will change. Of course, the MAC address of your routers and switches never changes. They're actually hardware program born into your NIC and all of that, so they remain static. The one thing that changes from the network is the IPv4 and the IPv6 address. So a MAC address is a unique number that is part of the NIC, like I said. IP address are assigned by the company or internet company and internet provider. I'm talking about the public IP address. For the private IP address, we're giving some range, which I will explain subsequent slide. So displaying displaying the addresses, check IP address on your system. All you need to do is to go to the command prompt and type ipconfig/all. Once you do that and you press enter, it will give you the DNS topics, it will give you host name, that device name. It will also show you the MAC address, that's a physical address. Yes, IPv4 address, IPv6, all those will be displayed. So this is one command you will always want to have around you to really get more information about the addresses on that network. And so for the IPv4 address, you can actually access the system, in other words, a host device. And then where do we go to? There's an icon at the lower tray. When you look at your system, you click on it and change the number there. So an IPv4 address, but in this case, is static. So two parts IP address, network and the host. So the IPv4 address have what we call the network portion and the network portions are represented with bit whenever bit of 1, while your host portions are represented with bit of 0. So usually what you see here with the network portion is that for you to get it clearly is that called subnet maps. For every class of IP address, there must be a subnet map. So the subnet map actually tells which part of the network and which part is the host address. Okay. For instance, if we're going to know that for looking at this IP address 192.8 is an IP address, okay, and then 255.255.255.0 is what we call the subnet mask for a class C. Okay, so we have subnet masks for A, for B, for C. For a class A network, it is 255.0.0.0. For a class B, it is 255.255.0.0. So 0 goes 0 for B. 255.255.0. So you can see here that this is actually first class. That's what we call the default subnet mask of an IP. So when you look at the subnet mask of that IP address, you'll be able to tell that ones are network and all the strings of zeros are actually classified as the host. So in this case, this subnet mask here is, you can see here, is 4, and the row of zeros here is 8. If you put all together, you get 32 bits. So when you convert 255 to binary, you get all this. You get all this. So you can see here, in the last one, you get 8 bits of zeros. Now, same also the IP address also converted. The subnet mask actually tells the portion that is actually meant to be used as the host. So in this case, where you have all ones, the network portion, and then the remaining zeros are actually referred to as the host portion. So from here, you have a formula you can use to calculate the possible number of networks you can get IP network, and then you can also tell what you can get for the host. So the formula for the network is you can use only called 2 to the power of n, where n represents the bit. Okay, so if you count this number of ones here, it's about 24. So you're looking at 2 to the power of 24, which now represent the network portion. These zeros, which is 8 bits, represent the host. But in the case of the host, we have a formula which is chosen by n minus 2, where n is the bit of zeros in this case for the host. Then when you look at this, for instance, you say 2 to the power of 8 minus 2, which is 2 to the power of 8 will give you 256, minus 2 will give you 254. So that actually 254 is now the possible number of hosts we can get on IP network. So for every IP address that goes to subnet mask, because no IP address, every IP address must go to subnet mask, we should be able to calculate the host. So with that, you're able to know the number of systems that will be connected to that network. So this is the IPv6. I explained this earlier. This is a further illustration to show some of the narrative of what I just explained. Look at the rules here. Omitting leading zeros. So we take off the leading zeros, and when we do that, you see what happens here. We now have it as 2001 for the DB8. You can see 0, 1, 0. So you're taking out the leading zeros. You go to the next one, where we now said use double for hex strings that come in that sequence manner. So when you have 0 bits of hex strings come in that line of, you actually take all of them as double column. So that's exactly what happens in this case. Yeah. Fully expanded, you can have it in this form. So this is how the IPv6 is actually being written. Okay. So we're looking at it side by side with the IPv4. The one thing I can assure you for sure is that when you start the CCNA, all this will be treated all over again in terms of submitting subnet, and all of that. To be taught, thinking that actually is where you're dealing with how network can be configured and all of that. But at the IT essential level, we want to identify different types of IP, know which class they are, how to configure them, set them up on systems, on network, and then create that connectivity. The logical layout has to be established. So this is static addressing, where you manually the IP address on the system. Like You can see here. Then if you look at the right hand side, this is for the IPv. The IPv6 is still maintain the same string of numbers, because in this case it's being compressed, and like I said, the subnet prefix 64 means that you're saying the entire length is 128, but 64 is the first 64 bit, which is regarded as a network ID or is a host ID. So with this now, the network begins to assign possible IP addresses that are under the 64 bit. So we talk about the IP address of the max, the default gateway. The gateway is the router interface to disconnected systems or to switch before the system, or it means that for the system, for each computer on that network, it must send information to go through the IP gateway, which is the next hub device. And so here is the DNS server, which command domain names. We are going to explain what DNS is in the previous class. The DNS helps to resolve the domain name of every given link. Let's say, for instance, cisco.com has its own IP address. Okay. And then, like we said, two types of networking addressing. So, that's what we just explained to us. And the dynamic, which is automatic. The automatic, you just choose automatic, and then the IP address is refreshed. So link local IPv4 address. So here for the IPv4, IPv4 device uses if the device cannot obtain an IP address. And then for IPv6 device, must always have a dynamic or manually configured link local IPv6 IP address. So here, looking at the diagram to your right, you can see that the link local IPv4 and IPv6. For the IPv4 device, it cannot obtain an IPv4 automatically on its own. You just have to get that configured on the network. But for the IPv6 device, must always have dynamic and manually configured for the link local, which is like a private IP address for IPv6. So that actually comes by default for the IPv6 because it will always pick the MAC address of the system within that network to create its own link local IP address. But unlike the IPv4, it has to be assigned. Essence of that is that it makes every system for IPv6, it makes every system on the network. Instead of having unique IPv6 addresses, it works with the MAC address of each of the systems on the network. Okay. And so there's a packet tracer here, which I said we use also for demonstration in terms of connectivity, connect one device to the other. Please, I want everyone to install packet tracer on the system. In the next class, I'll be using that to demonstrate some of these activities, so I can see how you can configure a physical network to be a DHCP, configure static IP address, and use the ipconfig /all to check the IP addresses and all of that. So I'll be using the packet tracer to show that. So network design, like network component network design, if you must design a network, you must look at the various key elements, in other words, the various key components in that line. So in this case, we have a wired Ethernet. This is where you plug in your network cable. We have a wireless one, which works with the antenna to actually check for the reception, so kind of cross around. And then you have the wireless Ethernet. This is actually another mode of actually connecting by wireless. So here, install and updating the NIC, the need to update the NIC on the system, which is the network interface card, to be sure everything is working, or else once in a while it gets corrupt, one or two reasons. So there's a need to do update on this, very important. And then you can configure a NIC. Wireless devices, including smartphones, also need IP address. Because smartphones work with IP address. Like I said, that's the means of communication. ICMP is also important when configuring the NIC. And the meaning of ICMP is Internet Control Message Protocol. This is actually where you check to see this connectivity. And what we usually use a command called ping. So you type ping, we'll be using it in the next practical class. The next class, which of course is the practical class. You type ping, maybe cisco.com or ping 888.8.8.8 or any of the usable IP address numbers. You should have a public IP address like this. And when you ping it, it actually responds immediately. So there's a lab to configure a NIC to use the DHCP, and like I said, I want to use the next class to demonstrate some of this before we move further. And there's a video you can watch to help you see how to configure a wired and wireless network. I want us to take advantage of this video to also help us. So connecting wired device to the internet. So you can see the NIC. This is the NIC port. To the NIC where you connect the cable to. So connect the cable to the device, connect the other end of the cable to a switch. So that means one end goes to the system, another end goes to the switch, or in some cases the patch panel, of course, which also is eventually connected to the switch. Where the cable between the wireless router, viewport, and the broadband modem, as you can see on the right. This is just shows how it's being configured and then being connected. So you always decide to use either wireless or use the wired. So in this case, we're looking at wired. That's why you can see the PVC cable with the RJ45 connector trying to use to connect to the system, and then the other end to the modem. So log into the router. How do we log into the router? Log into the router, open the browser, enter the IP address of the router, change the default username and password. So here is a typical wireless Cisco router. When it's bought by default, it comes with a default IP address which you enter on the URL as a uniform resource locator. And once you put that, you press enter, it brings up the. So the default username oftentimes is admin, and then you're good to go. Once you click it, it takes you to the page where you begin to change the settings. Or you can see here to your right. I also ensure that in the next class we'll do a practical on some of this to help us to go to the same knowledge. And then I'll give us assignment to do one or two stuff as well. So here you log into the router, change the default password, log into the new password, you set the DHCP address, like working on DHCP, and then renew IP address in case probably it's not picking, and then change the default IP address and log into the new IP. So we will demonstrate this in our next section because we're going to design topology on the packet tracer and do some basic configuration. But here, I actually want us to note that for a typical wireless Cisco router device, all the setups are available, and what is expected is for you to dictate whether it's going to be DHCP or static. With DHCP, you click on DHCP, and once you save, automatically start dishing out IP addresses based on the configuration. You can see here that we configured to be 10.10.10.1. You can see we're using something max, which is the default something max of C. Okay. So still on the wireless settings, you're going to configure the wireless LAN default, configure the SSID. And so what we're saying on the right hand side are the basic configurations we usually do on the wireless network, Cisco wireless router. And I want to advise, I employ all of us to actually look at it critically, because I'm going to be using this in the next class to configure a typical wireless router. So you might know how all this configuration is being carried out, and those of us who are already doing it, that's fine. And those of us who are new, for you to do a typical setup in a lab for our students to get connected to the internet. Okay. So it's still on the mesh or the wireless. So like I said, I'm going to be doing the practical. So another thing is what we call the NAC, which is network address transmission. It converts your private IPv4 address to internet routing, which is IPv4. So the NAC is actually what helps the network of the private, because the typical IPv4 address has what we call private and public. The private is the one that you actually have right to configure whichever manner you want. The class IP address is private are already there for us. And then the public IP address is the one that is being assigned by the INE. The INE is your assigned number authority. And so for the IPv4, we can play around. The private IPv4, we can actually play around with it. And what we're saying is that the private IP address is actually localized, is within the geographical location. In other words, it's actually an intranet IP address. And for you to actually use this to broadcast on the internet, you need to actually carry out a NAT. Okay, which is trying to convert the IPv4 to IPv4. And then we also will look at the quality of service here. To show us that the quality of service configure allows prioritization of specific traffic types. This creates some kind of priority. So that also will be looked into. In this packet trace activity, we'll bring up a packet trace activity and work on as well. And then decide to get this configuration. There's a video here which talks about the firewall setting. Like I said, we're going to do basic wireless configuration and then firewall. For this video, you need to watch this video to see how a typical firewall is being configured. But this video explains about the firewall settings. Like now you can see here, we have the DMZ configuration in LAN. DMZ is the military zone configuration in LAN. The typical Cisco switch that will be configured to the firewall settings. Typical firewall rules. So let's see. Hello. Hello.
Yes, sir, we are here.
Okay. I heard someone talking. Okay. So, you there? Hello?
Continue, sir. I think he's speaking to someone else.
Okay. Please give me your mic. So don't be distraction. Okay, so the inverter plug and play is not secure as a security risk. Of course, we have firewalls. The normal DMZ switch, when you plug it to the network and it's not configured, it's considered as plug and play. But we are saying that whatever is plug and play actually does not provide that security features, because you have to configure that device so that you can tell what you're permitting, what you're denying, and set up some policy to guide which particular packet you allow on the network, and that which you're not allowing on the network. So these settings actually are critical. We're saying that the firewall settings have to be looked into or configured such a way that it will provide some restriction on the network. So the demilitarized zone is a network that provides services to an untrusted network. So it means that when you're setting up your network in your organization, it's actually very important that you have a DMZ switch. DMZ switch is probably, in most cases, from your ISP, let it land on the DMZ switch. And from the DMZ switch, you can now take it to your typical LAN network. Then you distribute that. Once the firewall setting is carried out on the DMZ, automatically can actually filter which traffic comes in and new traffic. So you don't put your router directly. Most people, you just see them the ISP straight into the router. I mean, the router is your security house. More or less, it's the main the main device that house all the computers. So there's a need for you to actually introduce a device in between, which usually could be a DMZ firewall device, so that you can actually monitor inbound and outbound traffic. Okay, so the port forwarding allows traffic to specific ports. You can actually forward traffic, and port tracking to allow a temporary opening in the firewall to allow data to specific inbound ports or port range quantification or gain. Now, all this can be done on a typical physical router, which, like I said, will lead to configuration. We also configure the MAC address filtering so that you can actually see how you filter MAC addresses in the physical router to break that restriction. So you can also do what we call whitelisting and blacklisting of a known website such that you can actually allow. So this is quite important. And then this is the video for you to watch. And so please, like I said, let's get ready for the configuration in the next one. Okay. So the Internet of Things. The Internet of Things with IoT may connect to a pre-existing network or network of its own. So a smartphone contains IoT device. I remember IoT is how you allow network devices to connect to the internet and then have some level of control within one point. So from a smartphone contains IoT device. Remember, every other thing is connected. So IoT device is the packet tracer. If we click on the packet tracer, like I'm going to show us in the next class, we'll see all the icons of the packet tracer. You know, we have smart fan, we have smart, so all the smart, like this, most of the things you see here are actually like a smart home, where you have a smart door, you have smart, and if it's going to be smart, it must be internet enabled, because that's what makes it smart. Okay, so we need to watch the firewall, and then troubleshooting process, quite important. Why you set up your wireless connection, you set up your IoT smart network, you set up your wired network. There's actually need for troubleshooting because one or two issues are proper. So what are the ways to troubleshoot? Identify the problem. Remember we went through these 6 steps before. Identify the problem, establish a theory that has to do with that problem, and then test the theory to determine your cause. Very important. And then establish a plan of action to resolve the problem and implement the solution. So we also said, if you remember, looking at hardware troubleshooting, similar to the network, you verify the full system functionality, and if applicable, implement preventive measures such as avoiding the main findings, actions, and outcomes. So the same procedure carried out during the hardware part of this course, the same procedure you're using network. In this case, the environment is completely different in the sense that one is hardware based, but this is actually network based. And network requires you moving from physical layout to logical layout where you assign IP addressing systems, connect them with cables, and configure them to ensure that they actually are sharing resources. And then, as we see also, you can also carry out some basic tasks like MAC filtering, allowing some systems or disallowing some systems based on the MAC addresses, and then also doing what we call permit and deny on the network based on IP address. So the number of things that are done here, and then once you do this configuration, they are bound in the no browser. So these are the process of actually carrying out this steps. So you must be able to identify what the problem is. Is it that it's connecting and then timeout, connect, timeout, possibly the cable is bad, you need to change the cable or all of that. So these are actually ways to establish this theory. So let's identify the problem. So in this case, What problems are you experiencing with your device and network? Which software has been installed on the device? So this is more about the device. On the case of the network, you have to ask a number of questions. You're the one who have actually set up that network. If someone else, you need to also verify. So when you see shared files, you need to do some checks, and then are you sure the IP address is the same subnet or subnet map is different? You can have two systems. The one expect them to share resources. It's not possible. So all that has to be checked first to identify the problem before establishing the theory of probable cause. And then once that theory is confirmed, like in this case, you can check if the loose cable improperly installed, the ISP is down, and then the invalid IP address, DNS service issues. All these actually will have to be established first before you implement the solution. So that really comes under establish the theory. Okay, and then you test the theory. This is what we also said. Test the theory. Check that all cables are connected and then connect cables, reboot the computer or network device, log in different user, repair or re-enable the network connection, and then ping the device to see the connectivity or ping the default gateway. Now these are actually procedures of checking to be sure where the problem is, because you also do that by eliminating this part. Okay. 6 steps is to troubleshoot. So step 4 is to what? Troubleshoot a network. Which, like I said, step 6 is what? You now have a plan of action to resolve the problem and implement the solution. So you establish the solution. So if the solution is achieved in the previous step, further research is needed to implement the solution. So you look at help desk repair logs, see if previously issues resolved in the same manner. Technical website to check. So you have to establish a plan of action by using those means. And step 5 is that you verify full system functionality and if applicable. So now you've actually verified to see the system is working based on findings and implementation. The next thing is to implement preventive measures so it doesn't reoccur. Okay. So common problems and solutions. Problem leak LED light not leak. It's coming up to check what could be the problem. To use secure shell to access the remote device. You should check if that port is blocked. The SSH port is blocked. Definitely they cannot. It is port 22. Device cannot detect the wireless router. You also check to see why the device cannot detect the wireless router. Either the wireless router slide is hidden or not available. Unique. So Windows computer has an IPv4 address. If it has this number, then you know automatically it's a self address which you have to release and renew again to see it picks the right IP address. So remote device does not respond to whether it's different something max different class of network. Then you're trying to ping. So these are the things actually to check as a procedure to be able to narrow down the problem. So the same thing is applicable here. Device can connect to a network device by an IP address, but not by the host. So look at these issues and then begin to eliminate them one after the other. But this actually comes in the real world where after you do the setup, you have These are actually real life situations some challenges we face on the network. Like in the this case, an IP address conflict message is displayed when a new device. So you're trying to create a new device and you see a conflict, for instance. A conflict shows that probably the number of pool of possible IP address. Now you're trying to create a new device and the IP address is not available, and then it's trying to renew an IP address for that new device, therefore conflicting with an existing system. Or for instance, a system that shut down and then you bring it up on the network and that IP address has already been assigned to another system. But then you're trying to connect it to show conflict until you have to renew and then repeat. So these are challenges on different problems. And once you go through those problems, good news also is that there's a lab video also for you to watch problems actually arises and how they are solved. Okay? But then the basic principle of the configuration was go first before you now eliminate some of these issues. So primarily, it will be nice that we get the layout out. We do a design of our own topologies, show how the scales are connected, and then once we do that, we actually introduce one or two network and try to see if we can troubleshoot them. These are procedures, these are steps to identify problems and then possible solutions. So I advise that we walk through this the next class, see if we can actually admit them. So in summary, for this chapter 6, in summary, look at a configured device for wired and wireless networks, explain MAC and IP addressing the networks, configure wireless network, configure wireless network of small LAN, configure wireless settings, IoT device, all of them. So as we go through this, get the packet tracer ready, because the first 30 minutes of the next class I'll use it for the practical illustration. I think that will actually help us for chapter 5, 6, 7 as well. Then before we move on to the other part of the items, they help prepare our mind for the CCNA class. So far, any questions that will help me to explain further? Any question, please? Hello, are we there? Mary?
Yes, sir, we are.
Or we wait after the practical section? Hello? Mary? So far, Adams, Jacobo, any question? Shaibu? So are we okay with it? Hello?
So far, hello. I'm okay, sir.
Are we okay with this explanation?
I said, when we are to ask our question, we are resting them down. So in case you have a question, we'll put it across.
Yes. There are no questions for today. So, hello.
Hi, sir.
So we'll get a packet tracer and then get ready for that. Okay.
For me, I already have the packet tracer.
We've already installed it on our lesson, so
Okay.
it's already on our computer.
Oh Lord. So in the next class we'll be doing this and then. So how are we finding the assessment? Any issue?
Pardon, sir?
The assessment. Are we on with the assessment?
Yes, sir. Yes, sir. Yes, sir.
Okay, thank you very much.
Welcome, sir.
Quite early, and then because I know I'm taking it over to the next one. So see you guys on Tuesday.
Okay, see you too.
Tuesday. Thank you very much.
Thank you so much.
Bye.